Hi 8th graders, here's your first short video. I just want to tell you in this video you should be taking notes, and there is an assignment at the very end that you're going to have to turn in by Thursday, which I believe is October 8th. So if you don't have your composition book and then a separate sheet of notebook paper, go ahead and pause me and get that now. Alright, let's get started. Alright, so we're getting into chemistry and we're going to start talking about atoms and matter, but before we get into that, we're going to talk about some physical and chemical properties. Now, we've just been studying density, we've been studying mass and weight. It's really important that you guys have a firm grasp of density and a firm grasp of weight and mass, because we're going to use those to identify different substances. Why? It's because matter has different properties or characteristics. These characteristics are unique to that specific substance, just like you have characteristics that are unique to you. So you have unique characteristics, so does every single element and substance on the planet. So some of the useful properties that we use are density, that's what we studied last week, magnetism, melting and boiling points, whether or not the substance can conduct heat and electricity, and those are all great things that we use to identify an element or a substance. Alright, there's two kinds of matter, properties of matter. There's physical properties and chemical properties. Since characteristic chemical and physical properties for a specific substance, they never change. They're always the same, and they're independent in the amount of the sample. That means if I have 50 tons of water or 5 milliliters of water, I know the density of water is always 1 gram per milliliter. So because they have these specific characteristics, they become like the fingerprints that we use to compare and classify matter. So it shows here matter in the solid, liquid, gas form. We've got different kinds. We've got mixtures. We've got pure substances. It shows us ways of separating them, and we'll get into all of this much later in the units. But some physical properties of a characteristics is something to keep in mind when studying this, is to know, can I observe that change, or can I observe that property and know that it is not going to change into another substance? So physical properties of elements are shininess, hardness, if they're magnetic, if they can dissolve water, or if they are dissolved in water. So if I look at gold and I look at its physical property, its color is bright yellow. It's shiny. It has no odor. Its melting point's really high, 1,065 degrees Celsius. Its boiling point is even higher, 2,800 degrees Celsius. Gold has a very heavy density, or a very high volume. It occupies, since its volume is large, its density is, and its mass is going to be large, its density is large too. So the density of gold is always 19.31 grams per cubic centimeter. Chemical properties are a little bit different. We can't necessarily see chemical properties. We can't identify them by touch. But a chemical property is a characteristic of a substance that it describes its ability to change. A chemical property is going to mean that it can change into something else. And like physical properties, we use these chemical properties to classify substances. So this is not homework. This is just a test. Let's see if you guys think it's a physical or chemical change. Rusting. Now, if I take something and I'm changing it, I'm actually changing it into a new substance. The act of rusting is a chemical change. Flammability. The ability for something to catch on fire is a chemical property. So rusting and flammability are chemical properties. Magnetism, however, magnetism is not going to change my substance into something new. So whether or not it's magnetic is a physical property of that matter. Conducts electricity. Again, the ability to conduct electricity is not mean that my substance is going to change to a new form of matter or a new type of matter. So that conductivity is a physical property. Silver tarnishes. So if you have anything silver, like maybe your grandma's silverware, and you have to polish it or anything, silver turns black over time, and that is actually a chemical reaction. So the ability for silver to tarnish is actual chemical property of silver. Melting. Melting even though the form changes shape, it goes from a solid to a liquid, the actual matter itself is not turning into a new substance. So melting, freezing, boiling, all of those things are physical properties. All right. So we talked about properties. Let's talk about when those properties actually take effect. So a substance when it undergoes a physical change, it's still the same substance even after the change. A substance that undergoes a chemical change is going to produce a new substance with new properties. So over here in my the diagram, physical changes, there's only a change of state, meaning they go from solids to liquids to gases, even maybe to plasma. The new substance has the same properties of the old one. No new substance or substances are produced. So the example is ice to water to steam. They're all H2O. They did not change into H3O or H2O2. They're all still water. In any of these changes, we can get the original form back. So if you started with ice and we end with steam, we can condense the steam back down to liquid water, and then we can take that liquid water and freeze it back to ice. So a physical change may also include changing the shape of a substance. So if I cut a bunch of paper into pieces, it's still paper. That's a physical change. Cutting wood into pieces is still wood. Molding a sculpture is still cement or marble. Chemical changes are different. This is where one or more new substances are created. The new substance is completely different from the original. It has properties that are different from those of starting materials. And another thing, you can't easily get those original materials back if you can get them back at all. So for instance, when I talk about cooking, all cooking is when you're actually using heat. These are, so if I look at most cooking, I'm applying heat. I'm actually chemically changing that. So if I cook a raw egg, I can't go back from this cooked egg and turn it back into the raw egg. That is a chemical change. I'm done. Same thing, if I bake a cake, that is a chemical reaction that occurs, chemical bonds to form when my cake batter gets heat added to it. So again, this is a chemical change. Burning, the ability for remember we said flammability was a chemical property. When it actually becomes flammable and it's on fire, that is a chemical change. I can't take this ash and go backward to get that paper. If I leave a car outside for time and it starts to rust, steel rusts, and rust is a chemical property. It's a chemical change. I can't necessarily go back to the brand new car I had before. So like I just said, physical changes was when the form of the substance has changed, so the shape, the form, but we don't produce nothing new. So all changes in the state of matter, vaporization, condensation, melting, freezing, sublimation, all of these are physical changes. Chemical changes, remember I said, is when matter produces one or more new substance through chemical reactions. And we're going to see that chemical reactions actually break down a substance into two or more substances, or can combine two or more substances to make a new one. The pretty cool thing is that everything on this earth around you is made up some combination of only the elements you see on the periodic table, and there's only 92 that occur naturally in nature. So everything we see on this earth, everything that we encounter every single day, the beauty, the different thoughts we think, those are just combinations of different atoms. That's pretty cool. Some more examples of chemical change, combustion, so fire. Remember, our product after something catches on fire is completely different from what we started with. Electrolysis, this is pretty neat. You'll probably do this in high school. This is how you break water back down into like hydrogen and oxygen. You actually are adding electricity to it, which causes the hydrogen molecules to disassociate from the oxygen molecules, and you actually get hydrogen gas and oxygen gas that come off separately. Oxidation, this is just where, for instance, if we talk about a specific metal, this is where that metal combines with oxygen over time to produce rust. That is a chemical change. Lastly, tarnishing. These are brass, silver, any of those pretty shiny metals are going to tarnish. Does gold tarnish? No, that's not a chemical property of gold. But, so what happens is that sulfur combines with that metal to create that black tarnish that we see, and that is a chemical change. All right, so for your homework, your paper, there are 7, I believe 7 things, or gosh, you guys are lucky, 5. 5 things, and I want to see if you think this is a physical or chemical change. So just write physical or chemical on your paper and turn this into me by Thursday, October 8th. See you guys in class.